everything, 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 fling, everything, 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 everything is awful. Oh, everything, everything, everything.
Hello and welcome to this discussion of failure. We tend to think of failure in the worst possible terms, as something that we want to avoid. But in research and in life, failure is a reality. The real question is, what do we do with failure? Professor Amy Edmondson of Harvard University has come up with a spectrum of failure. On the horizontal axis, you'll see that it goes from blameworthy to praiseworthy. That is, there are different kinds of failure. Some kinds of failure we blame people for, rightly so, but other forms of failure are actually praiseworthy, worthy of being held up as honest attempts to try to deal with an issue or a problem. In this short presentation, we're going to go through these different kinds of failure to find that there are certain kinds of failure that are in fact productive kinds of failure, the kind of failure that we oftentimes will encounter when we're engaged in research. The first type of failure that Professor Edmondson talks about is deviance. That's the conscious violation of a prescribed process or practice. An example of deviance is Lance Armstrong, the world-famous bicyclist who won multiple Tours de France, but he did so while breaking the rules having to do with doping, which allowed him to exceed his natural human capacity. Eventually he was caught, and he was punished by having all of his titles taken away from him. Inattention is an inadvertent deviation from process or practice. You might remember the Mars Polar Lander. In 1999, at the beginning of the year, this lander was launched to land on Mars to do scientific study. 286 days later, on December 3rd, communication was lost with the lander. The plan was for the Mars lander to gently land on the surface of Mars. While it was in descent, a parachute would come out to slow it down, and then thrusters would engage. Once the lander was on or very close to Mars' surface, it would gently touch down. A software error misinterpreted some vibrations as being the lander landing on the surface. When the thrusters cut off, the lander was still 40 feet above the surface, and it quickly dropped to the ground and was lost. Another form of failure is lack of ability. That's an absence of skills, conditions, or training to execute a task. Imagine, for instance, that I was to be suited up and sent into a Major League Baseball game. Well, the fact is, I don't have the skills to be a Major League Baseball player, and I would fail bigly. The same might be true of somebody who is elected president, who has very few skills and very little training for the job that he's been elected to. While Donald Trump may have skills and abilities as a business person, his skills as a politician are lacking. And so we see that in the first year to year and a half of his presidency, he is floundering, trying to figure out how to do his job. This is a form of failure that was unnecessary. Process inadequacy is adherence to a prescribed but faulty or incomplete process. That is, the individual is following the rules, but the rules themselves have flaws that lead to failure. An example of this is from the Oscars a few years ago. You might recall that Warren Beatty came out and announced that La La Land was the winner of the Academy Award for Best Picture. Well, a process error in the way that the presenters were given the awards allowed Beatty to get the wrong information. So he was announcing one of the Best Actor awards when in fact he was supposed to be announcing Best Picture. After a few seconds, people figured out that there was something wrong, but by then the damage had been done. It was one of the great failures in all of entertainment history. Up to this point, we've been dealing with forms of failure that are to some degree unnecessary and not very helpful to learning and future success. Task challenge begins our discussion of useful failures. This is a task that is too difficult to be executed reliably every time. That doesn't mean that the task can't be executed reliably every time, but failure can be associated with the fact that you're dealing with a complex process that may be very, very difficult to overcome. Take, for example, the difficult prospect of building a robot that can walk. Now, as human beings, we find walking to be quite an easy task. That's because we are able to see, so our eyes send messages to our brains to let us know how our walking is going. We have a sense in our body of where our various body parts are, and so that helps us to maintain our balance. These are things that have to be built into robots in some way, shape, or form to keep them from falling over. Of course, with each failure came better understanding of what it takes to make a robot be truly efficient, so that the robot designers and engineers have been able to improve their designs such that this robot can go over some pretty treacherous terrain successfully. Some tasks are difficult because they involve many moving parts. That is, that the process is very complex. And when it comes to complex processes, it is easy for the many elements of the process, when met with some sort of novel circumstance, to fail. Take, for instance, the two space shuttle accidents, major accidents that have happened over the course of that program. You had Challenger, which is pictured here, where an O-ring that was meant to keep explosive material from high heat failed because the Challenger had been left out in cold circumstances, and these O-rings, which were believed to be resilient to the cold, in fact froze, and then they came apart, allowing the mixture of the fuel and the heat to explode Challenger. Likewise, when it came to Columbia, some foam that came off of the rockets for Columbia hit the heat tiles on Columbia, knocking off the heat tiles so that when it re-entered the atmosphere, it heated up and then exploded. In both cases, you're dealing with a complex process that ran up against an unknown or unintended sort of novel experience, and that caused the failure. Then there's uncertainty. Uncertainty is associated with a lack of clarity about the context that leads reasonable actions to wind up with undesired results. Take, for example, kudzu. Kudzu is a lush green vine that grows very well in the American Southeast. Kudzu first came to America in the 1870s from Japan, and people quickly realized that it had some special properties, including the ability to suck up massive amounts of water, and it helped with the problem of soil erosion. And so some folks thought, well, this is a good way to conserve soil. We will plant kudzu. The problem is that the American Southeast has a perfect combination of wet and warm that allows kudzu to grow at tremendous rates. What happened very quickly is that kudzu overran the South, destroying structures and causing up to $6 million per year in property damage. The idea behind kudzu was a good one, but because kudzu wasn't fully understood, the context created a failure. Hypothesis testing is a systematic attempt to test an idea which often fails. Hypothesis testing failure is routine in science and the arts. This is the business that we are in, which is taking an idea and running it up against reality to see if reality fits with what our thinking is. This is what happens all day, every day, in science labs, in artists' studios, all of the kinds of things that we associate with research and creative activity. And a lot of that failure is failure that we never see. The artist throws away her canvas. The hypothesis is tested and shown not to be supported by the data, and the researcher moves on. A lot of this is done in private, and I think that that's part of the reason why it seems that science is full of nothing but successes, is because the failures are hidden from view. But it's those failures that ultimately lead to the successes. There's an old story about Thomas Edison and how he tried out 10,000 different designs for the light bulb before he finally found one that worked. Whether you're a fan of Edison or not, the story illustrates the point that what we see as the successful light bulb is backed up by hundreds or thousands of failures. The final form of failure that we'll talk about is exploratory testing. This is when an individual attempts to expand knowledge but ends with undesirable results. We see examples of these kinds of failure in books like this, Fieldwork Fail, where field scientists shared their stories of some of their failures in the field. For instance, this scientist accidentally glued herself to a crocodile while attaching a radio transmitter to the crocodile. That sounds like a pretty scary thing, but this scientist was willing to share to show how failure is a natural part of the research process. And this one's really funny. This woman accidentally peed on a jaguar's marked tree, and the jaguar pursued her for 3 weeks in the field. That sounds like a fail to me. Another example comes from the work of a scientist named Haeckel, Ernst Haeckel, who was a well-known scientific illustrator in the late 1800s who made the drawings you see on the top of human embryos in various stages of their physical development. Some interpreted these pictures to suggest that human beings went through all of the evolutionary stages of all of the living beings on Earth before they finally emerged as human. Now, that was a wrong interpretation, though his drawings were very much correct, or very close to correct. But this failure also led to some important insights, especially the insight that there was an evolutionary process in place, and that organisms went through that. Previous to this, many people thought that human beings were fully formed inside of the body, and that our growing up was simply us becoming bigger versions of what we had been before. These drawings suggest, and correctly, that that was a wrong idea. And this is also said to have had some impact on Darwin's thinking about evolution, in the sense that it reveals a kind of a process that Darwin later finds to be a driving force behind the adaptation of species. What these examples of productive failure suggest is that failure is part of a larger constructive process of leading to success or creative kinds of outcomes, that we try repeatedly and find ourselves failing, but in those failures we are entering into an iterative process where we try to figure out where's the failure, what could we do differently next time, such that at some point we may reach success. Sometimes failures are failures, but sometimes failures are ways of learning that will ultimately lead us to success. So, what should we take away from this discussion of failure? Well, the first thing is to expect failure. Failure is a natural part of research and of creative processes. The second thing is that we need to communalize failure. We need to discuss failure with others. Number one, to realize that it is a normal part of the process, that everybody experiences it, but also to communicate certain dead ends that others might not want to follow, because therein lies failure. When we have tried and tried something and it continues to fail, then sometimes we need to say, hey, yeah, that's not working. We need to learn when to walk away from failure and when to stick with it. And that's why we have to reflect on failure. We have to reflect on the process, what went wrong, why it went wrong, and try to figure out whether it's something that we can fix or if we need to move on. Finally, we need to respect failure and continue failing, because in failure, that's where we're going to find the path to success. But as everyone knows, including the Nobel Prize winning physicist Richard Feynman, if a guy tells me the probability of failure is 1 in 100,000, I know he's full of crap. That is, that failure is far more common than success. But it's through that iterative process, time plus failure is going to lead to success as we repeat and try to figure out where the problems are. We stick with it, we persist, and then we finally succeed.
Everything, 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 everything. everything, everything, everything,